Hello to everybody, I'm Federico Carlini. I'm a TA on qualitative and quantitative data limited dependent variables. This is the first lecture of one series of lectures on matrix algebra. My mail is fcarlini@creates.eu.dk, and if you have any problem on these lectures, you can send me a mail. Why this is important? Because in the course we will see one model, the regression model, that is done like that. Y is equal to x beta plus epsilon. The regression model, the OLS, that is expressed in a matrix notation. Then we need to understand what is a vector, and we need to understand what is a matrix. Then a vector is a n tuple of numbers. Usually in our case are real numbers. We can indicate with v, and it has usually n components. Then it's v1, v2, vn, with vi, where I runs from 1 to n, that is a real number. And this is the basic element that we need to learn in this course. For example, one vector, usually the vectors are column vectors. Then we put, the elements in vertical. And this is n by 1 vector, and an example could be v 1, 2, 3, 4, where the first component is 1, the second component is 2, the third component is 3, and the fourth component is 4. Okay. And the second thing that we need to learn is a concept that generalizes the concept of vector, and this is the matrix. And a matrix is a rectangular array, and in which the elements we can call A, I, J. In the sense that A is a matrix, if we can write like that: A11, A12, A1n, A21, A22, A2n, A31, A32, A3n, etc. AM1, AM2, AMN. Okay, and this is a M by N matrix, and this one is, for example, in the example before, then if we take this example, is the matrix X. This is the matrix. And for example, a vector is y or beta or epsilon. Okay, usually we indicate with the I the rows. Then, for example, here we have the ith row. And the generic column is called J. Column, and then here we can have the jth column, and then with the I and J we can find what is the element that we need, for example, in order to do the calculations. Okay, this is okay. What to say? Okay, this matrix we can see in this manner. We can say that, for example, this is a vector. This is another vector. This is another vector. And inside there are many vectors. Then we can say that a matrix is like a composition of vectors, for example. A, we can say that there is A1 that is is done by these elements. Then we attach close to it A2, that is this vector, etc. till AN. Or we can say that is a composition of row vectors. What is a row vector? A row vector is indicated with the V transpose and is done by this V1, V2, Vn, and this is 1 by n vector. And then we can see A as a union of 1, 2, 3 m vectors, m row vectors. Then A1 prime, A2 prime, AM prime, where each of these A's are vectors. Okay, later we will discuss about the properties of the operation that we can do with matrices and vectors. But for now, we can talk about some special matrices and some special matrices that occurs in our course. For example, we have the identity matrix. That is a special matrix, m by n. I want to recall that an n by n matrix, when the number of rows is the same number of columns, is called a square matrix. The identity matrix, that is a square matrix, is one matrix that is done like that. We have the ones on the principal diagonal, and everywhere we have 0, everywhere else. And this matrix has one property that if we multiply by a matrix that, for example, is a m by n by E is equal to E by A that is equal to A. Then the identity matrix doesn't contribute on the product of matrices, but we will see later. Another matrix that is important to know is the triangular matrix. That is a matrix that, for example, is always a m by n, then is a square matrix that have all the elements, for example, here, over, above or below the diagonal. And this is called triangular. And another special matrix that you need to know is the diagonal matrix that we can call D, that is always a square matrix, then m by n, and have all the numbers on the diagonal then. 2, 2, A3, 3, A, N, N, here 0, 0, 0, 0 everywhere, and 0 everywhere. And why is important this diagonal matrix? Because, for example, the identity matrix is a special case of a diagonal matrix where all the diagonal elements are 1. And why we need to know it? Because, for example, the variance of epsilon given x in the course, it will be a sigma square multiplied by E. And we need to remember that this is a diagonal matrix because